Now let us proceed with Compton effect and try to obtain the relation between theta. If we rightly remember the Compton scattering, it was like this. Now this is phi and this is theta. So rightly going back to the two important equations in terms of conservation of momentum, what we have is we used to have an equation along x-axis, and what was that? That was mv cos theta equals h times nu minus nu dash cos phi, and I'll call this as equation 1. And then we had another equation along vertical axis, and that was mvc sine theta equals h nu dash sine phi, and obviously here was c. Okay, now this is my equation 2. Now if I divide these two equations, so dividing 1 and 2, okay, I have mvc sine theta by mvc cos theta equals h nu dash sine phi divided by h times nu minus nu dash cos phi. So we will have some cancellations, and what we will come up with, okay, what we'll come up with is sine theta by cos theta is tan theta, and that will be that will be nu dash sine phi by nu minus nu dash cos phi. All right, and I can write it like this. If I write tan theta is sine phi divided by this will be nu by nu dash minus cos phi. So what I did here is I have divided numerator and denominator by nu dash, and with this I have come up with this equation. So we can have this equation in terms of lambda, that is sine phi divided by lambda dash by lambda minus cos phi. So for nu you got to use c by lambda, for nu dash c by lambda dash. When you'll use these things here, c and c is going to cancel, and this lambda dash will come up, and lambda will be in the denominator. So now we have what we have. We have the Compton shift, and that is delta lambda is what is basically lambda minus lambda dash minus lambda is h by m naught c 1 minus cos phi. So this is our Compton equation, right? And if I divide this equation by lambda, so what I'll get lambda dash by lambda minus 1 is equal to h by m naught c lambda times 1 minus cos phi. All right, I should name this equation, say 1 for the time being, and let's see where we go. So we will have this lambda dash by lambda, and you can see this lambda dash by lambda can be substituted in this equation. So substituting second in 1, what we are going to get is tan phi. So tan phi, this is my 3. So what tan phi is going to be, so we have tan theta here, and then we have sine phi Now instead of this lambda dash by lambda, we have h by m naught c lambda times 1 minus cos phi. Then we have minus cos phi here. Okay, that's the case. So let us use some symbol here. Say, let us assume that this h by m naught c lambda is equal to say alpha. So say this alpha is h by m naught c lambda. Now, so what's going to happen here is we can write this equation in terms of frequency as well. So this will be h nu. For lambda, we will be using c by lambda, right? So what we'll get is h nu by m naught c square. So this is my alpha, which I have chosen in the above equation, and I can use the half angle formula for this sine phi, and we know that this sine phi is twice sine phi by 2 cos phi by 2. So we can do that. So in doing that, we'll have tan theta equal to twice sine phi by 2 and cos phi by 2. Okay, divide by, this is now what is this? This is here I'm gonna use alpha, right? So for this I will be using alpha times 1 minus then we have cos phi times minus cos phi. Okay, this should be the case, and when we resolve this, we'll get this tan theta equal to it will be twice sine phi by 2 cos phi by 2 divide by 1 plus alpha times twice sine square phi by 2. Okay, so now when we move on, so we can see here this square and this phi by 2 will go, and what we'll be left with will be this is here cos phi by 2, and here I have sine phi by 2. So cos theta by sine theta is cot theta. So what I'm going to get here is this tan theta equals to twice cot phi by 2 divide by what we will be left in the denominator is 1 plus alpha, and alpha is already defined as a constant whose value has been taken as h by m naught c lambda, right? So so with this equation we would like to have, so this is our required relation that correlates the angle theta that the scattered electron makes with the x-axis to the angle of scattering phi that the scattered photon makes with the axis with x-axis. Now, if this phi is chosen as 0, so what we get here is this cos phi by 2. It will be infinity, and therefore, what about tan theta? Okay, what will be tan theta in this case? Tan theta will be infinity. Now, if tan theta is infinity, I can have tan theta equal to tan pi by 2. So this tan can be removed, and we have theta equal to pi by 2. Now, what does this mean? This means that the photon goes unscattered, while the electron moves at a right angle to the direction of photon. So nothing happens to the photon. It does not scatter but electron scatters to an angle equal to pi by 2. Now, if we take another case as phi equal to pi by 2, so what will happen in this case is that this cot phi by 2 that we have, that will be equal to 1. So that implies that tan theta in that case will come out to be it will come out to be 1 upon 1 plus alpha, if we take it like this, and 2 and 2 will be cancelled from that equation. So in this case, what we obtain is that theta is positive, and this theta lies between 0 and 90 degree. Now also, if we go back to this delta lambda that we have, we know its value. What's its value is if we go here, if we go with this this delta lambda is h by m naught c times 1 minus cos phi, and what we obtain here is that in this case, what we are going to obtain is the value of this delta lambda, that's Compton shift, that is h by m naught c for this case, and that's already calculated as 0.0242 angstrom. Okay, for phi equal to pi by 2, theta is positive, and theta can lie between 0 and 90 in this case. Now, what does it mean basically is that the photon gets scattered, right? The photon gets scattered and moves at right angle to the direction of incidence, right? So it moves to the right angle to the direction of incidence, if this is a photon. So the change in the wavelength at that time is 0.0242 angstrom, while the electron moves in any directions between 0 and 90 degree. So electron can have any direction between 0 and 90 degree, and the photon will, the direction of photon is perpendicular to the direction of incidence. Now, if we take on another case, say we'll take phi equal to pi. Now, if we take phi equal to pi. Now, phi equal to pi. Now, in this case, what's going to happen is we will be getting 2 times h by m naught c. So I'll get it because phi equal to pi means that this cot phi by 2 is 0, and that implies that tan theta is 0. Now, if tan theta is 0, that means theta is 0, right? So if theta is 0, we will have this Compton shift in this case, that's delta lambda, that will come out to be 2 times h by m naught c. All right, so what does it mean now? And its value, if we calculate, it will be 2 times 0.0242 angstrom, and that will be nearly 0.0484 angstrom. So what does it mean? This means that the photon reverses its direction with a change in the wavelength equal to 0.0484 angstrom. So it's going to reverse its direction at this wavelength, while the electron moves in the direction of incident photon. So this is the photon coming back, okay, and and this is the electron moving along the direction of incident photon. Thus, the maximum change in the wavelength takes place. So this is the maximum change that can take place when the photon gets scattered in the direction of incidence. All right, so I'll stop here and we'll discuss some other parameters in the next video that are linked with the Compton effect.